Students, welcome to my class. Today we will do some examples of connected bodies. Contact, and some bodies are moving over the pulley and some kept on the inclined planes. We will do a set of problems today. Set of applications. Let's start with the connected bodies. Okay, let's say two bodies are taken. As this body, or you say it is a block which has a mass of m1 in contact with another mass. Okay, it is a second mass. Okay, these two bodies are kept in contact with each other on a smooth surface. Let's say it is a smooth surface. It has a mass of m1 and it got a mass of m2. Okay, students, we have to find out the acceleration of the system when an external force acting on it, and as well as the contact force in between the two surfaces. Here it leads to numerous problems. You can add one more body to this. In this way you can connect a number of bodies, and every time you will find the tension, the contact force in between the two surfaces in contact, and as well as the acceleration of the system. Let's take two bodies and we are applying an external force on it. Let's say it is the external force which is acting on the body. Okay, students, here in this situation what we have to do? First we have to find out a contact force which is acting in between the two. Okay, students, let's name this contact force as T. Actually it is the pair of the two forces. We are taking these two forces by means of Newton's third law. To every action there must be equal and opposite reaction. And what force it causes on this body, this also applies the same force on. That's why we mention them as T and T. Both are acting in opposite direction. The force acted on this body is shown in this way, and it is here. Okay, students, let's say the two are in contact, that's why they are moving with a constant acceleration of A. To solve this, first we have to draw a free body diagram for this one. Let's say this was a free body diagram. Here the weight of the body W1 is acting vertically downwards. It balances with the normal reaction. Okay, students, additional to that, one force is acting in this way, and a tension force. Okay, that is the contact force. And for the second body, we have to go in the same way. Okay, it is the weight acting vertically downwards. Let's say weight V2, W2, and it is the normal reaction. Name it as N2, automatically it will be N1. Okay, and a force is acting on. It is the force, that means contact force, which is providing acceleration to this body. Okay, in this diagram, the two forces, that means weight and normal reaction, get cancelled with each other, and here also the same thing will happen. Okay, students, then after we have to treat these two bodies as a single system. Okay, if you apply the Newton law here, what you get? F is equal to ma to get the acceleration. Here m is equal to sum of the masses m1 plus m2. Okay, then F is equal to m of m1 plus m2 of A, and acceleration we got F upon m1 plus m2. It is the acceleration of the system, students. Then after we have to find out the contact force. See this body m2 is moving under the effect of this contact force T. This contact force T is making the body to move means what? It is providing the acceleration. Okay, then this force must be equal to the product of this mass multiplied with the acceleration. And I am writing the relation here. T is equal to m2 of A. Okay, students. Now just substitute the value there. It is m2 of acceleration F by m1 plus m2. In this way, we can find the tension and as the acceleration. Let's say m1 is equal to 5 kg. Okay, students, we are doing one example quickly. m2 is equal to 10, and we have to find out the acceleration. Just simply apply the formula. You can do it fastly. F by m1 plus m2, and applied force is say it is 15 Newton. Okay, students, F 15 by 5 plus 10, then automatically it is equal to 1 meter per second square is the acceleration. In the same way, we can find the same. m2 is equal to 10, and it is F 15 by 10 plus 5. These two get cancels, and we get tension which is equal to T. Okay, students, the tension force, that means what? The contact force which is acting on this body is equal to 10 Newton. In this way, we can solve a problem which has two masses. Then what about the system which has more masses? That means more than 2. Maybe it is a 3 or 4 or 5, whatever it may be. It can be done very easily. Say, students, this time we are taking a 3-body system. Okay, let's say it is the first body and it is in contact with the second body, and we have one more, the third body. The 3 have been connected and kept on a smooth surface. Let it has a mass of m1, m2 and m3. Okay, an external force of magnitude F is acted on, then the system tends to move with an acceleration of A. As usual, we have to find out the contact forces T1 and as well as T2 here. Okay, students, let's find the common acceleration. As you know that F is equal to sum of the masses multiplied with acceleration, and we get A is equal to F by m1 plus m2 plus m3, and we have to go with the tension. We are finding the tension T2 here. This T2 is responsible for the motion of this block. That means it is providing acceleration. Then we can write it as T2 is equal to m3 multiplied with A, and T2 is equal to m3 acceleration we had. Okay, students, now is the time to find out the T2. See this, the difference between the two. Here T2 is in this direction, T is here. The difference between the two is providing acceleration to this black m2. Then we can write T1 minus T2 is equal to, it is providing acceleration to this block, m2 multiplied with the A, that is T1 is equal to T2 plus m2A. Already we had T2 as m3F upon m1 plus m2 plus m3 plus m2 acceleration of m1 plus m2 plus m3. Then we have to find out the T1 as what? m3 or m2 plus m3 of F upon m1 plus m2 plus m3. Okay, quickly we do a problem. Let's say m1 is equal to 2 kg, m2 is equal to 3 kg, and m3 is equal to 5 kg. Okay, and apply force F, say it is equal to 20. Then he is asking us what is the acceleration is. It's simple. A is equal to 20 of 2 plus 3 plus 5, 20 by 10, and we got an acceleration of 2 meter per second square. Maybe in examination he will ask you what is the tension between the two. Then automatically go with the relation. T1 is equal to what we get, m2 plus m3 of F by, okay, m1 plus m2 plus m3, okay, 3 plus 5 into 20 by 2 plus 3 plus 5, it is 20 into 8 by 10, 2s are 16 Newton, and we have to find out the T2. T2 can be had easily. It is equal to m3 into A. It's a smart thing. m3, what you gave, 5, and acceleration we got 2. Okay, in this way you can find out what is the tension and as well as the acceleration when in case of the 3 body system, and you have to adopt the same system for the 4 body or 5 body. Even it is pushed or pulled, you have to apply the same relations. Okay students, here it can be asked in another way. See the students, okay, here the same problem we are doing is a block 1, and we have one more block 2, the beam kept on a smooth surface, and it has a mass of m1 and it has a mass of m2, and these are the center of mass, and it is the line of action of the force. This time what is said, a force is acting in this way. Okay students, then he is asking us find the acceleration of the system and as well as the contact force which is acting the body. It is the force which is acting, making an angle of theta with the horizontal, he can give. Okay, and what you have to find, in this case you have to resolve the force into components. Okay students, horizontal and as well as the vertical, horizontal and vertical. It might be F cos theta and it is F sin theta. Here F cos theta is responsible for the motion of the body. That is, you can write F cos theta is equal to m1 plus m2 of A, and A is equal to F cos theta by m1 plus m2. Okay students, in the same way we have to find out the contact force. As you know that T is equal to m2A, here we are considering this, m2 F cos theta by m1 plus m2. Okay students, quickly we do a problem by taking theta as 45. I'm taking theta as 45. Okay, and m1 is equal to 3 kg and m2 is equal to 2 kg. See what we did. First we have to find out the acceleration. F, here F is equal to 20 Newton. Okay students, and put the values. What you get, A is equal to F cos theta by m1 plus m2. F 20 into 1 by root 2. Okay students, by 2 plus 3, that is 20, root 2 by 2 into 5, 2 is 2 root 2 meter upon second squared. Okay students, in the same way, the tension can be had as M2A, that is M2. How much is it? 2 into 2 root 2, 4 root 2 Newton. Here, one force is acting, making some angle with that you can do. Okay students? Here this problem can be asked in another way. You have to follow the same. By giving 3 blocks or floor blocks, and might be it is asked in this way. It is a smooth surface, 2 bodies are kept here, and one more body we have. They are connected by a string. The string is massless and inextensible, and a force is pulling that body. Okay, he is asking us what is the tension in the string and acceleration of the system. You have to follow the same thing. Consider this one M1 and it is M2. You have to find the acceleration. A is equal to F by M1 plus M2. We got it? And we have to find the tension. T is equal to M2A. Okay students, then M2F by M1 plus M2. Okay, and sometimes maybe the question will be like this. He is pulling with a force of F, making an angle of theta, then automatically it is F cos theta, and you have to just change the values. A is equal to F cos theta by M1 plus M2. T is equal to M2F cos theta upon M1 plus M2. Okay students, here what we did, and we resolved this force into components. It is F sin theta and it is F cos theta. And how we resolve? Here you know about the resolution of the vectors. Let's say it is the force. Okay, and we constructed a triangle here, theta, and we are writing the components. Let's say it is Fy and it is Fx. Okay, Fx we have to find. It is, you know that cos theta is equal to what? Adjacent by hypotenuse. Fx by F, that is Fx is equal to F cos theta. It's a component of the force along the x-axis. In the same way, sin theta is equal to opposite by hypotenuse, that's Fy by F, and that is Fy is equal to F sin theta. Here it is. Okay, here in this way you can resolve the vectors into components and you can find out the desired results. Let's do one more problem students. It might be asked like this. Here it is related to the wedges. The two, we are doing the immovable pulleys. Let's say it's a wedge of inclination theta here, and we connected a pulley over this. Okay, a string is moving over. It is inextensible, the string, and the massless. Okay students, and these two masses are connected this way, and he's asking us what is the acceleration of the system and as well as the tension which is present in the string. Let's say it is M1 and M2. Take M1 is greater than M2, students. M1 is greater than M2. And see the results. Okay, students. Here, if M1 is greater than M2, obviously it will move down with an acceleration of A. And tension would be like this. It's a tension. And it's the weight of the body which is acting vertically downwards. Here it is the weight. It is W2. Okay, students. We are drawing the free body diagrams of mass M1 and as well as the M2. Okay. FBD of M1. Okay, it's the point mass M1 and it is the weight of the body and it's the tension in the string. Okay. We said it is coming down, means the weight of the body is more than the tension. Weight is providing the acceleration. And you know that weight is equal to M1G. And we are writing the relation between the two. We are finding the net force. That is here, W1 is greater than T. Then the difference between the two, W1 minus T, give a net force. W1, it is M1G, minus T is equal to M1A. Let's say it is the equation 1, students. Okay. In the same way, we are drawing the free body diagram of the second. Okay. Let's see. It is the inclined plane making an angle of theta and the mass is kept here. Obviously, the weight of the body, W2, is acting in this way and it is the normal reaction. Okay, students. Here we are resolving the weight into components. It is M2G cos theta and it is M2G sin theta. Here we did before. You know that how to resolve the vectors into components. It is the theta. Okay. Let's see. It is the tension in the string. Here in this case, tension is making the body to move up. It is moving in this way. Okay. And we can write T is greater than M2G sin theta. Okay, students. Then T minus M2G sin theta is equal to net force, that is equal to M2A. Let's say it is the 2. We have 1 and 2. Adding 1 and 2. What to get? M1G minus T plus T minus M2G sin theta is equal to M1A plus M2A. Okay, students, here TT get cancelled and G of M1 minus M2 sin theta is equal to A of M1 plus M2, and we got the acceleration is equal to G of M1 minus M2 sin theta by M1 plus M2. In this way you can find the acceleration. Quickly we will do a problem. Let's take theta as 30 and put the values M1 and M2 are 2 and 5 and we will get the acceleration very quickly. Okay, students. In the same way we have to find out the tension. Okay, we have to substitute this value A in one of the equations. Either it is or this. Okay, we are I'm taking this equation to find out the tension, students. Okay, see how we get M1G minus T is equal to M1A. Okay, and T, what to get? M1G minus M1A, that is T is equal to M1G minus M1. A we got G of M1 minus M2 sine theta upon m1 plus m2. Let's simplify. We can write it as t is equal to m1g into m1 plus m2 minus m1 squared g, okay, plus m1 m2 sine theta whole divided by m1 plus m2, and finally we can write t is equal to m1 squared g plus m1 m2g minus m1 squared g plus m1 m2 sine theta divided by m1 plus m2, and these things get cancelled. What we get? GF. Okay, m1 m2 is common. We can write it as m1 m2g of 1 plus sine theta by m1 plus m2. Okay, it's the tension in the string, because the values of acceleration, okay, this one, and we had the tension. In this way you can find out the tension and acceleration, okay, in the string when it's kept on a wedge, that is immovable pulley we say. Okay, the results can be changed if you change the direction of the motion of the body. In this case it is moving down. Here think m2 is greater than m1 and we'll get the results. Okay students, let's go with one more. Here let's say it's a wedge, okay, and we connected a pulley here, and a mass is connected in this way, and it is one more. Okay students, let's say it is making an angle of alpha here and it is beta. Let's say it is m1 and it is m2. Okay, say m1 is greater than m2, then obviously the body will move in this direction with an acceleration, and it is the tension in the string, and here it is tension, and the body will move in this way. Okay, let's resolve this one. It is the alpha and its weight is acting vertically downwards. Let's draw the free body diagram. It's an inclined plane and it is alpha. A body is kept over and is the weight which is acting vertically downwards. Okay, we are resolving the weight into the components. Okay students, here if it is alpha, then it is the alpha. Automatically it is m1g, okay, sine alpha was this, and it is m1g cos alpha. m1g cos alpha is balancing with the normal reaction, and m1g sine theta is connected with the string which is providing the tension there. Okay students, here m1g sine alpha, this one, okay, if you watch it carefully you will find m1g sine alpha is greater than tension in the string. That's why the body is moving down. The difference between the two provides the acceleration, that is m1 let's say 1. Now we are taking this plane. Okay students, is the beta, and the same body is kept here. It has a mass of m2 and weight is working vertically downwards. We are resolving it into components. Okay students, it is beta automatically. It is m2g cos beta, and it is m2g sine beta, and it is the tension, is the direction of acceleration, is the normal reaction. Normal reaction balances with m2g cos beta. The same thing which is happening here, and is balanced with m1g cos alpha. Here in this case also, T is greater than m2g sine beta. See the difference. That is T minus m2g sine beta is equal to m2 acceleration. Say it as 2, and we are adding 1 and 2. m1g sine alpha minus t plus t minus m2g sine beta is equal to m1a plus m2a. Here t get cancelled, and g of m1 sine alpha minus m2 sine beta is equal to a of m1 plus m2. Then we get a is equal to g of m1 sine alpha minus m2 sine beta by m1 plus m2. Okay students, with this equation you can find out the acceleration. If you substitute the acceleration, one of the equations, you will get the tension, and you can do the numericals also. For example, you say it is 37 degree and it is 57, then you can find out the acceleration of the system if you give the mass. Okay students, let's find the tension in okay, we are substituting the value of A in the relation m1g sine alpha minus t is equal to m1a. Okay, then it can be written as m1g sine alpha minus t is equal to m1 of g into m1 sine alpha minus m2 sine beta by m1 plus m2. Okay students, t can be had as, okay, what t we are taking it out, that is m1g sine alpha minus m1g of m1 sine alpha minus m2 sine beta upon m1 plus m2. Okay students, then you can write it as m1g sine alpha of m1 plus m2 minus m1 square g sine alpha plus m1 m2 g sine beta whole divided by m1 plus m2. Okay students, further it can be written as m1 square g sine alpha plus m1 m2 g sine alpha minus m1 square g sine alpha plus m1 m2g sine beta. these factors get cancels, and what you get? 2 now m1 m2g sine alpha plus m1 m2g sine beta by m1 plus m2. Here we are taking m1 m2 g as common, that is sine alpha plus sine beta whole divided by m1 plus m2. In this way we can find out the acceleration. If you ask m2 is greater than, then you have to do the same case. Okay, the terms will change. Understanding, students? I hope you followed this lecture. If you think it is a good lecture, please subscribe my channel and share this video with your friends also. Welcome back to Quest EduPhysics, students. Today we are discussing about the movable pulleys. In this video we are going to learn about the movable pulley. The Atwood machine is a fixed pulley. You know that. Here, what is the movable pulley and how it functions, we have to know. As same what we did in fixed pulley, we are going to find out the tension and as well as the acceleration of the system. But we will do in different way, and finally we will get some tricks to solve the equations very easily. And let's say it's a rigid support, students. Okay, here we have a pulley and we got one more. Okay, students, it's one more pulley. It is fixed here. Okay, and we suspended a mass and we attached another mass here. Okay, students, let's say it is mass m1 and it is mass m2. Okay, students, we have to find out the tension in the pulley and as well as the acceleration. Here these arrows are indicating the tension, and let's say is the acceleration, and it is the direction of the acceleration. In this case, if you watch it carefully, m1 is less than m2. The main purpose of pulley is, by doing less work, we have to lift more weight, students. Doing the less work, but we are lifting more mass. Okay, that's why intentionally it is shown in this way. Okay, students, let's say the length of the string which is attached or the pulley is equal to L. Okay, the total length, I am taking it as the L. L is length of string moving over the pulleys. Okay, students, L is the length of the string which is moving over the bullets. If it was this, is the fixed length. Okay, and here also a fixed one. Here this part doesn't move, and the remaining this one will move. Okay, students, let's say this length as y2. Obviously, it might be equal to y2, and this one, which is moving over, call it as y1. Okay, students. Then we can write the total length. L must be equal to, let's say this length, I am taking it as y0. It is a fixed one. y0 plus y2 plus y2 plus y1. Okay, students, and it can be written as L is equal to y0 plus 2y2 plus y1. Okay, is the total length of the string, students. Here it's all happening in a given interval of the time. Here we are differentiating this length with respect to time. Differentiating with respect to time. What we get, students? Derivative of L by derivative of t is equal to dy naught by dt plus 2 of dy2 by dt plus derivative of y1 by dt. Okay, students, here it is the constant, length is the constant, so the differentiation becomes 0, and it is also a constant, that's why it is 0, and we get 2v2 plus v1. Okay, students, again differentiating with respect to time, we get 0 is equal to 2 of dv2 by dt plus derivative of v1 by dt. As you know that v by t is acceleration, and we get the acceleration. It is 2a2 plus a1 is equal to 0, and we yield, okay, 2a2 is equal to a1. Okay, students, here in this way you can relate the accelerations. Okay, here I am writing it as the positive because the accelerations are working in against directions. Okay, students, let's say a2 is equal to a, then we get a1 is equal to 2a. Means what? This one moves down with an acceleration twice of this. Okay, here it has an acceleration of a, and this pulley, that means what? By means of this pulley, this one moves down with the acceleration which is twice of this one. Okay, students, here let's find out the magnitudes of the acceleration, and I said it's a common acceleration it has, and also we need to find the tension. Okay, students, Here we got A2 as A. And now if you draw the free body diagrams, and it is M1G and it is M2G, students. Okay. If you draw the free body diagram of this one, the difference between the weight and as well as the tension provides the acceleration. Here in this case, okay, we are writing the FBD of M1. Okay, students, it can be drawn in this way. It is M1G and it is the T. Here M1G minus T is equal to M1A. That means acceleration A1. That is M1G minus T M1 into 2A. Okay, students. Similarly, if you draw the free body diagram of this part, okay, it is T and it is the T and it is the 2T. Okay, free body diagram of M2 we are drawing. You can draw it like this. It is 2T is equal to M2G. Since it is moving up, 2T minus M2G is equal to M2A1. A2. That is 2T minus M2G is equal to M2A. Since A2 is equal to A2. Okay, it is the equation 1 and is the 2. Okay, students, we have to add these equations. It is M1G minus T is equal to 2MA. Multiplying with 2, what I get? 2M1G minus 2T is equal to 4MA. And we have this equation. Say it as 3 and 2. Add in 2 and 3. What we get? 2T minus M2G plus 2M1G minus 2T is equal to M2A plus 4 M1A is M1. Isn't it, students? Then what you get? Here T get cancelled. G of 2M1 minus M2 is equal to A of 4M1 plus M2. And we get the acceleration. Acceleration of the system is 2M1 minus M2. Okay, students, of G by 4M1 plus M2. It is the desired acceleration, students. Okay, students, in this way we can find out the acceleration as 2M1 minus M2 of G by 4M1 plus M2. Then after we are going to find the tension in the string, students. Tension in the string. Okay, students. Here we are taking this diagram. If you draw the free body diagram, you will find is the tension. It is M1G. The difference of the two, M1G minus T is equal to M1 A1. Okay, and we wrote it as M1G minus T into 2a. We had the value of the a. It is m1g minus t is equal to 2m1 into 2m1 minus m2 of g whole divided by 4m1 plus m2. Okay, students, then t can be written as m1g minus 2m1 of 2m1 minus m2 of g by 4m1 plus m2. Okay, students. Further, it can be written as t is equal to m1g of 4m1 plus m2 minus 2m1 into 2m1 minus m2 of g whole divided by 4m1 plus m2, and it is 4m1 square g plus m1 m2 g minus 4 m1 square g, here we multiply this, plus 2 m1 m2 into g, okay, by 4 m1 plus m2. Okay, similar terms get cancels and we get tension is equal to 3 m1 m2 g by 4 m1 plus m2. By using these relations, you can find out the tension and as well as the acceleration of the system, students. A1 is equal to 2a. A simple thing, students. This pulley is moving up. That means the length which is decreasing in this amount must be equal to the increasement of the length in this part of the string. Okay, let's say the pulley raised up to this one. That means it is the decreasement of the length of the pulley with respect to the string appears to be increasement in this. That means if it rises to a distance of 2y, then the increment would be in this one. Okay, here the increment is twice of that. That's why we get 2 times of acceleration all the time. Directly you can do that. By practicing the problems, you can understand this thing in a right way. Friends, right now we did a 2 pulley system. Now we are going to do a 3 pulley. Okay, let's say it's a rigid support. Okay, students, from where we are suspending the system. It is a pulley, and we have one more. Okay, students, the string is moving over, and is passing over one more pulley. Okay, here is the weight which has been suspended, and it is connected like this. Okay, students, and one more weight we are hanging it. Okay students, the same principle we are using here. Here, see, it is raising up and it is raising down. Let's say it has an acceleration of a2 and it is a1. Okay. These are the fixed position students, and these things doesn't change. But the remaining will changes. Let's say the length is equal to these parts we are taking. This remains constant. 1, 2, 3. Okay. Decreasement of these lengths appears to be increasements in this. Okay. Let's say this part is y2 and obviously it is y2 and it is y2, and this one is y1 students. Okay, it is y2 and it is y2. Okay students, we can write 3y2, okay, plus y1, and it's the constant length. So it is y0, it remains constant. Okay, again you differentiate it, you get dl by dt is equal to 3 of dy2 by dt plus derivative of y1 by dt plus. Okay students, here it is equal to 0. 0 is equal to 3v2 plus v1 plus 0. Again differentiating with respect to time, we get 3 of dv2 by dt plus dv1 by dt is equal to 0. Okay students, and it is the acceleration 3a2 plus a1 is equal to 0, or you can write a1 is equal to minus 3a2. Okay students, say this. The acceleration is equal to 3 times to this. Let's say it is a and it is equal to 3 to a. Getting me students? In this way we can register the accelerations. Here if you starts doing the problem, you can understand how the acceleration can be calculated by counting the number of strings which are attached. Okay, practicing make you perfect in this. We got the acceleration. Then we have to find out the tension and as well as the acceleration of the system. Okay students, now we are using the free body diagrams. Let's see. For this, say it is m1 and it is m2 g, tension, tension, tension and tension. Okay, obviously it is equal to 2t. Okay, let's take FBD of m1. What to get is the tension, it is the weight. Okay students, though m1 is m1g minus t is equal to m1 into a1, that is m1g minus t is equal to m1 into 3a. Okay, and if you watch that, the second one, FBD of m2, what you get, t plus t plus t. Okay students, 3t minus m2g is equal to m2 a2, that is 3t minus m2g is equal to m2a. Okay students, let's eliminate one of the factors. Okay students, and we will get the tension and as well as the acceleration. I'm multiplying this equation with 3. I get it as 3m1g minus 3t is equal to 9m1a. Similarly, it is 3t minus m2g is equal to m2a. We are adding the equation, students. What you get? 3 m1g minus m2g is equal to a of 9m1 plus m2, and we got acceleration as g of 3m1 minus m2 by 9m1 plus m2. Okay, students, in this way you can find out the acceleration. Let's substitute this acceleration in one of the equations and we will get the tension. Okay, students, in this way you can find out the acceleration and as well as the tension in a 2 pulley system and as well as the 3. Okay, students, in this way we found the acceleration of the system. Let's find the tension. Okay, students, you know that m1g minus t is equal to 3m1 into a. Already we did this. We are substituting that value. Okay, students, further we are writing it as t is equal to m1g minus 3m1 into 3m1 minus m2 into g by 9m1 plus m2, and it can be written as 9m1 square g, okay, plus m1 m2 g minus 9m1 square g plus 3 m1 m2 g whole divided by 9m1 plus m2. These terms get cancelled. We get it as 4m1 m2g by 9m1 plus m2. In this way, you can calculate the tension in the string, students.